Hey everyone, welcome back to the channel. In today's video, we're going to break down two essential network protocols, TCP and UDP. You've probably heard these terms thrown around in the world of networking and cybersecurity, but what do they actually mean, and how do they impact the way data moves across the internet? By the end of this video, you'll not only understand the difference between TCP and UDP, but also how each protocol works in different real-world applications. Plus, we'll discuss use cases, performance, and where each protocol shines. So let's dive right in. Introduction to TCP and UDP. Before we get into the details, let's first understand where TCP and UDP fit into the bigger picture. Both of these protocols operate at the transport layer of the TCP IP model. This layer is responsible for ensuring that data is transmitted across a network efficiently and reliably. Think of the transport layer as a postal service. It's responsible for getting your data from point A to point B. But how it gets there and how reliable that process is depends on what is TCP. TCP, which stands for Transmission Control Protocol, is a connection-oriented protocol. This means that before any data is sent, TCP establishes a reliable connection between the sender and receiver through a process called the three-way handshake. The three-way handshake involves three steps. SYN. The sender sends a synchronization, SYN, request to the receiver. SYNAC. The receiver acknowledges with a SYNAC packet. ASIC. The sender sends an acknowledgement, ASI, and the connection is established. Once the connection is established, data is sent in segments, and TCP ensures that each segment is delivered in order and without errors. If a segment is lost or corrupted, TCP will retransmit it. This makes TCP extremely reliable, which is why it's used for applications like web browsing, HTTP, HTTPS, email, SMTP, and file transfers, FTP. Some of the key features of TCP are reliable delivery. TCP ensures that all data is delivered to the receiver without loss. Error checking. It detects errors in transmission and requests retransmission if necessary. Flow control. TCP controls the rate of data transmission, ensuring that the sender doesn't overwhelm the receiver. Congestion control. It adjusts the transmission rate based on network conditions to avoid congestion. TCP is perfect for situations where data integrity is critical. For example, when you're downloading a file from a server, you want to make sure that all parts of the file arrive intact and in the right order. What is UDP? Now, let's talk about UDP, which stands for User Datagram Protocol. Unlike TCP, UDP is connectionless and doesn't establish a connection before sending data. This makes it faster and more lightweight than TCP, but it comes at the cost of reliability. UDP simply sends packets, called datagrams, from one device to another without checking if they arrived successfully or in the right order. There's no retransmission of lost packets, no error checking, and no flow control. So in a way, UDP just sends and forgets. This might sound risky, but UDP's simplicity makes it ideal for applications where speed is more important than reliability. One common example is video streaming or online gaming, where you need real-time data delivery. An occasional packet loss won't ruin the experience. Some key features of UDP are low overhead. No handshakes or error checking means UDP has less overhead than TCP. Faster data transfer. Since UDP doesn't wait for acknowledgements, it can send data faster than TCP. Best effort delivery. UDP sends data without ensuring delivery, making it best for real-time applications. UDP is commonly used in VoIP, Voice over IP services, online multiplayer games, live video and audio streaming, comparing TCP and UDP. So, how do TCP and UDP compare side by side? Let's look at the key differences. Connection versus connectionless. TCP is connection-oriented, meaning it establishes a connection before sending data. UDP is connectionless, meaning it sends data without establishing a connection. Reliability. TCP ensures reliable data delivery through retransmission and error checking. UDP provides no reliability, but it's much faster for real-time applications. Use cases. TCP is used for applications where accuracy and integrity matter, like web browsing, email, and file transfers. UDP is used for real-time applications where speed is critical, like video calls, gaming, and streaming. Performance. TCP has higher overhead because of its connection setup, error checking, and flow control. UDP has lower overhead and is faster but can lead to packet loss. Real-world applications. Let's explore some real-world applications where TCP and UDP are used and how their unique characteristics fit the needs of these applications. TCP applications. Web browsing. When you visit a website, TCP ensures that all elements like text, images, and videos are delivered accurately. Any missing or corrupted data would ruin the browsing experience, so TCP's reliability is crucial here. File transfers. When downloading or uploading files via FTP, TCP guarantees that the entire file arrives in one piece, making sure nothing is lost. Email. Sending and receiving emails over SMTP relies on TCP to ensure that the content is delivered in its entirety. UDP applications streaming media. When you're watching a live stream on YouTube or Twitch, the priority is to deliver the video in real time. Occasional packet loss is acceptable because the stream must continue, and that's where UDP shines. Online gaming. In fast-paced online games, players need immediate feedback. Losing a few packets is less important than having quick, real-time interactions. VoIP calls. Voice-over IP services like Skype or Zoom use UDP to ensure real-time voice transmission. Even if a few packets are lost, the conversation continues uninterrupted. Performance and troubleshooting. When deciding between TCP and UDP, it's important to consider the trade-offs. TCP is great for reliability but can be slower due to its connection setup and error-checking processes. UDP, on the other hand, is faster but less reliable. So, how do you troubleshoot when something goes wrong? With TCP, you can use tools like Wireshark to inspect the three-way handshake or ACH SYN packets to troubleshoot connection issues. For UDP, you might be looking for packet loss or jitter in real-time applications like video streaming. Conclusion. So, to recap, TCP is the go-to protocol for reliability, ensuring that data arrives in order and without errors. It's great for applications where data integrity is key. UDP is all about speed and is used in real-time applications where a little bit of packet loss is acceptable. Now you know the differences between TCP and UDP, and you understand when to use each. Thanks for watching. If you found this video helpful, make sure to like, subscribe, and hit the bell icon for more tech breakdowns like this. I'll see you in the next video.